So here is the last example. Two vectors r and s, where r is 3r minus 8j and s is 5i plus kj, are on a coordinate plane. Find a value for k element of the reals such that the magnitude of r is the same as the magnitude of s. And will there be a value for k such that r and s are going in the same direction? So that second one requires a little bit of thought, but can actually be done as a visual proof. So go ahead and try these yourself and come back when you're ready. So ignore this bit. As I said in the last video, this bit is actually from the last video. I forgot to cut off it properly. So the square magnitude of r is 73. So if you're doing equal magnitude, it's best to get the square of the magnitude. Otherwise, you'll get a lot of square roots everywhere. So the square of the magnitude of r is 73. And the square of the magnitude of s is 25 plus k squared. Because if r equals s, well then r squared is the same as s squared. That just comes from logic. So we end up with k squared plus 25, or 25 plus k squared is 73. So k squared is 48. So k is plus or minus 4 root 3. So those are the values for k. It said value singular in the question. So either 4 root 3 or minus 4 root 3 work fine. And the second one said that will there be a value for k such that r and s are going in the same direction? Well, r is going down and to the left, and s is going to the right. So it's only restricted to this blue semicircle. Otherwise, it would start becoming positive I, which we don't want. So they're never ever going to go in the same direction because they're opposite to each other. So we can therefore conclude a proof without words that r and s will never be going in the same direction, and we won't have to do any weird trigonometric things at all.